Assalamualaikum and hello. Let's continue with the last subtopic of this chapter, subtopic 1.6, where in this part we are going to learn how to state the type of reactions in organic chemistry, and there will be three of them. First is substitution reactions, followed by addition reaction, and the last one is elimination reactions. Let's go to the introduction of reagents and sites in organic reactions. When you want to do the organic reactions, you have to identify reagents used in those reactions. And those reagents sometimes can be classified as electrophile or nucleophile, but it's depending on the type of site they attack. Let's go to electrophile first. Electrophile means electron loving. So there will be an electron deficient species, and electrophile will accept electron from an attacking nucleophile. Electrophile can be either neutral or positively charged, depends on the questions given. And last one, electrophile also known as electrophilic reagents. It means that reagents with less or deficient electrons. These are the examples of electrophiles. The first one, you can see cations with positive charge, such as H+, H3O+, NO2+, and the next one you can see there will be carbocations, and followed by Lewis acids such as AlCl3, FeCl3 or BF3. And the next one, you can also classify oxidizing agent as electrophile. The next one, you got neutral molecules with empty orbitals. These also examples of electrophile. And last but not least, metal ions such as Ag+, Cu2+. From before, I said about type of site they attack. So I want to introduce electrophilic site, which are molecules with low electron density around a polar bond. It means that there will be different in electronegativity for that bond. For example, you got partially positive and partially negative between carbonyl C double bond O, and you can also see the difference in electronegativity in haloalkanes between carbon and halogen. And last one, you can also see the difference in electronegativity between this polar bond of COH hydroxy compounds, where OH is much more partially negative. So these are examples of electrophilic site. There will be low electron density around a polar bonds because the electronegativity already been splitted between two different atoms. Next one, we go to nucleophile. Nucleophile means nucleus loving. It means that nucleophile is an electron-rich species and also called as electron pair donor because there will be a lot of electrons density at nucleophile, so they tend to donate the electron. The next one, nucleophile can be either neutral or negatively charged, opposite to electrophile. And nucleophile also known as nucleophilic reagents with higher electron density. For example, nucleophiles can be anions with negative charge such as OH-, Cl-, Cn-. And the next one, you got carbanions, which is carbon with negative charge. And you also got Lewis base such as NH3, H2O. The next one, reducing agent, also classified as nucleophile. And last example, neutral molecules with lone pair electrons also can be acted as nucleophile. So for nucleophilic sites, there are molecules with high electron density around the carbon-carbon multiple bonds. Take a look at this sentence. This term means that you have to take a look at your compounds such as alkenes, alkynes, or benzene ring, because all of these examples contain high density of electron based on the presence of double bond in alkene, triple bond in alkynes, and double bond in the ring form for benzene. So I hope you all clear how you want to detect and see the difference between electrophile and nucleophile. That's all for this video. I'll see you in the next one. Bye!